Okay, ladies and gentlemen, we have here a prominent figure in the realms of alternative cosmology. He has an unwavering commitment to the challenge mainstream narratives. He's captured audiences worldwide with a topic that's very divided. He's here to discuss why we are on a flat Earth. Ladies and gentlemen, Flat Earth Dave!
All right. A lot of you have seen a lot of my stuff. Great. I'm going to go very fast today. For those of you that are new to this, just listen, maybe write down a note, but write it down fast because I'm going to go through 5 more points while you're writing it down. And then come to our tent later and let's have a deeper discussion about it. So let me just make sure this is working. Here we go. The Flat Earth Awakening, ignorance is no excuse for denying reality. So, we're all ignorant to everything we don't know. I was ignorant to the Flat Earth until I learned about it. Um, you have your choice. Is it flat or is it a spinning globe? And we're going to look at all the alternatives today. I used to think, and many flat earthers thought when they first, people that heard about the flat earth, they said, this is a psyop to discredit all the other truth movement. And I said that because, of course, the earth is a globe, and that's what this has to be a psyop. But it's not until you look that you see. If I don't answer any of your questions, that doesn't mean that the earth is a globe. It just means I didn't get to that question. So come talk to us and have an open mind and just listen and see what's happening. So, there I covered that. So one of the things is you can go on YouTube, Google, whatever, and search, and you can find stuff on UFOs. You can find, fairies caught on camera. You can find Loch Ness Monster, no problem. Anything you want, dragons, ancient aliens. But when you get to flat Earth, you get this little warning on the bottom says that it's a debunked cosmology, stupid. But they don't tell you how it's debunked because they can't, because it hasn't been. Um, we're indoctrinated as small children. Before we could even talk, your parents probably put a mobile over your crib with planets in it and Sesame Street had astronauts. And try taking the ball away from a baby. What's worse than that? Try taking a ball away from a big baby. All right, okay. Especially when your whole life world is built around that. So yesterday in Ian's talk, he brought on he didn't have any sound, so I'm going to play the sound today. But you have to remember, think about a jet fighter, a pilot in the Air Force. These guys are the best of the best stuff, right? The right stuff, right? 4,000 applicants all want to be above that. They want to be astronauts, and they come up with this guy, all right? Let's see what he has to say.
I'd go to the moon in a nanosecond. The problem is we don't have the technology to do that anymore. We used to, but we destroyed that technology, and it's a painful process to build it back again. But going to Mars should be one of the next series of
best of 4,000 applicants.
Do. The first step should be going back to the moon for a number of technical reasons and exploration reasons, and then after that, Mars, maybe high orbit in Venus atmosphere.
Smartest, the brightest.
Going to Europa. There's all kinds of targets to go to, places of interest in our solar system. The only limit to a human future is in our own imagination.
The best of the best, right there. So Ian was afraid of using a word, but I'm going to use the F word and the R word when I describe some things today. All right, and those words are frigging and ridiculous, but some of you may think of other words that I may or may not be thinking, so we're going to go through that. What difference does it make? The shape of the Earth does not matter, all right? So we have three models here. We have the globe. Well, we have three things here. What's in common with all of them? The COVID and the flat Earth disk floating in space. They're all dog crap, all right? None of them are real. This is what they want you to, they think flat Earth is on the right there. So what is flat Earth? What is flat Earth? Well, it ain't that. All right. This is you Google flat Earth. That picture shows up. That's a false. It's a false binary. They show you the globe or that. Which one is it? It's neither. They want you to believe that that word disk floating in space. This is the flat Earth. Here's a balloon at 127,000 feet. The Earth is spinning 1,000 miles an hour, faster, almost twice the speed of sound. And the sun is right there. Look at the light spot right underneath it. It looks like a local light because it is a local light. And whenever we send balloons up to this height, the sun is never over them. It's kind of like almost at the same height, whatever it is. So what is the sun? I don't know. We don't know. Right? In the heliocentric model, they want you to believe that this is going on. You're spinning at 1,000 miles an hour. You're orbiting at 66,600 miles an hour. You're chasing the sun at 500,000 miles an hour. That's moving sideways at millions of miles per hour, but nothing ever changes, right? Let's take a look at what that looks like. This is going by a Mach 8.6. It's a rocket sled, right? Can you fathom speed? Just showed it to you. That rocket sled went by at Mach 8.6, right? You have to believe that we live on a lumpy rock, surrounded by curved water, surrounded by high pressure air, adjacent to a void, a vacuum without a container, and we're traveling 10 times faster than that. 10 times, right? We're chasing the sun at 100 times faster than that. These are things that you can't fathom, therefore your brain just shuts down. And, we see stuff like this. When we go outside, we see that. And they want you to believe that's going on. Those speeds, which you can't even fathom. But your common sense tells you that it's stationary. A little kid looks out at a pond while he's fishing, and everything tells him it's stationary. We're not moving. It's level. But then he goes to school, and they go, oh, no, everything you feel and sense and know intuitively is wrong. So that breaks a kid. Here's a small earthquake while these kids were in this pool, and look what it does. Just a small little shaking of the earth. Right? It's not moving at 66,000 miles an hour in a curved trajectory. Everyone's like, oh, we're already moving that speed, so you don't notice it. Go in a car, 100 miles an hour, get a dinner plate of water, fill it with water, and have that car speed up or slow down or take the slightest turn. That water is gone, right? So, funny thing about earthquakes is they cause tsunamis, and when a tsunami hits like Australia, it'll wrap around Australia and continue on the other side. It wraps around continents, right? But it doesn't wrap around Antarctica. Here's a big earthquake that happened, a big tsunami, and it went like that, right? It goes along Antarctica just like the sun goes along. It doesn't go around. Here is my little simulation. These balloons at the side are going 1,000 miles an hour to keep up with where they are over the earth. The ones at the top are just pirouetting like this. They're not moving, right? If there was one halfway in between, it would be going 500 miles an hour on a different plane, right? These are things that people don't even think about, but this is what you have to believe, right? But when we look at reality, here's the balloon going up. Is that Earth spinning faster than the speed of sound? Is it, what's going on there? This is observable reality, but they want you to believe insaneness, insanity. Jumping over to, we've known for 2,000 years. The Greeks figured it out 2,000 years ago. Eratosthenes with his sticks and shadows that they teach all the kids in school, right? So here we go. On the right, Eratosthenes theorized, well, the sun's infinitely far away because the rays come in parallel. No one's ever seen parallel rays. And he said, all right, I'm on the right there. The sun, there's no shadow on my stick, and then my buddy over on the left side there, he has a shadow on his stick at the same time, 500 miles away. Like, how did his buddy get there? How did he know it was 500 miles away? The story is he walked and he counted his paces. Can you imagine that? 7,958. So what? Oh shoot, what number am I on? And so he's there, and he's in a different time zone a little bit, depending on where he is. And somehow he knew to take the measurement at the exact same time. And they say that proves the shape of the Earth. When on a flat, stationary Earth, we have the sun over Eratosthenes on the right. And over here on the left, there's his buddy. You can do the same math, figure out the sphericity of that flat surface. Math is not reality. Math is a description of whatever you want it to be a description of, right? Neil deGrasse Tyson, who says he doesn't have enough time to address flat earthers, makes video after video after video strawmanning us. All constantly. And he says, well, the Eratosthenes, finally, they replied to us showing that it works. He goes, yes, it works with 2 wells or 2 sticks, but it doesn't work with 3. It does. It works with 100. It works with as many as you want. This is something that works on both the flat Earth and a globe Earth. This is what we all observe. These are called corpuscular rays. Nobody ever observes this, which is what Eratosthenes would have to believe. And back then, they believed in a geocentric Earth. Well, if we have a geocentric Earth, how do they have an infinitely far sun circling this little tiny Earth? Right? It doesn't make any sense, but people don't put it together. Here's a flat table with some beer cans on it. I have a light over one of them. And so by measuring those shadows, you can check the sphericity of that table and determine that it's a sphere. It's obviously a sphere because of the shadows. So Eratosthenes is wrong. Earth is flat. Seasons, check this out. On a globe Earth, we have a morning sun, which is 93 million miles away. At noon, we have it's warmer, it's hot, and the sun is still 93 million miles away. And then in the evening, it's colder and the sun is still 93 million miles away. On a flat Earth, we have a more distant sun, a little cooler, closer sun at noon, and more distance in the afternoon. The sun is just passing by, right? And so that's why the heat of the day is in the middle of the day. Here it is on the Mercator. Is this a Mercator map? On just a flat map showing you the Tropic of Cancer, which the sun is at now. That's why we're warm in the inner north. And then in December, it goes out to the Tropic of Capricorn. This is what it looks like on the real map of the world. And right now, our sun is doing that tight inner circle. That's why we're all sweating our butts off in here, right? And the sun's high in the sky. In a couple of months, in 6 months from now, the sun will be out south, so it'll be farther away. It'll look lower in the sky, farther, colder, lower. That's our winter, and that's summer in the outer south. Here's a little example. A guy's holding let's say it's 10 feet over this person. You got a nice heat lamp. Person's, yep, that's right above me, and I see it straight above me. And the other person, he sees it at a 45-degree angle. He's farther away. It's not above him. It's farther away, which is lower. Farther is lower. It's not lower. It's the same height. And so if that person walks over, keeping it at the exact same height, the guy on the left sees it dropping. The guy on the right sees it rising. It's now his summer and his winter, lower sun, higher sun. That's how seasons work. Seasons actually prove flat Earth. They like to say seasons, the tilt of the Earth. If the tilt of the Earth caused the seasons, then every morning in June it would be bitterly cold because the sun is way down on the horizon. We're 3.5 million miles farther from the sun during our summer. None of that makes any sense. None of it at all. Sunsets is a big one. How does the sun set on a flat Earth? And this is one that the globe, there's the different groups of people. We have the anti-flat Earth globe, people that are just disingenuous and constantly strawman and never pay attention. Then there's the other people that are ignorant, like we all were before we learned whatever it is that we learned. And that was one that got me. Like, hey, how does the sun set over the ocean? I've seen it disappear from the bottom up. Have you? Has it gone behind a physical curve, right? Here's the sun. How do you explain that on a flat Earth, right? How do you explain that? Well, here's the sun going away, and it's got that cloud deck, and it's just going beyond the cloud deck. So it'll disappear from the bottom up. It'll disappear from the bottom up. Here it is a little farther zoomed out, and it's going behind an opaque cloud deck because it's above the cloud deck, and it'll disappear from the bottom up. Here's the sun. And it looks like it's setting, but we zoom in, we can open up that space and see it's not really setting. It's above the apparent horizon. What is the horizon? It's the horizontal eye zone, okay? It's where your perspective draws a line that appears to be at eye level. It appears to be at eye level, but it's not. We have 3-level paths. Let me just animate that. So the one on the left is a terrestrial point of view. That line is level. It's shown on the bottom right. It's just a different angle. I'm looking at it from the table. The one on the bottom right is viewed from a celestial point of view, a raised point of view. And the one at the top is an actual sunset. The sun's going away. It's going by what I call the atmospheric deck of opacity. The atmosphere becomes opaque over distance, and it just goes away, just like it's set on the bottom left there. It's set on the top right. This is all perspective. And when you're far enough away, everything appears to happen at eye level. Here's the moon. Have to hit play. Is that moving? Yeah, there we go. So the moon's not going down, it's just going away. But it appears to be going down. Just like that line I showed you. It appears to be going down, just like that. Right? It's following the same trajectory as that level line. That line is level. And it's how we see from the ground, right? Here we are. We're in a city. It's noon. We're looking straight up. 12:30, 1 o'clock, and the sun goes beyond that building. Now, is that sun below the horizon, or is it just beyond the building, right? It's just beyond the building. Now, if you could see that sun by raising yourself up, if you can float up in the air, or let's say you can go backwards 5, 10, 20 miles, right? At 20 miles, the top of that building will appear to be at your eye level, right? So let's take a look. So here's a perspective grid. We put our guy in here. That line at his eye level, that's where his eye level is, right? Throw a mountain in there. The tops of that mountain, let's just say it's thousands of feet above his eye line. So it's thousands of feet above his eye line. So the sun will just go away and go beyond the mountain, just like it went beyond the building. So if we moved him backwards, I'm just going to move the mountain forward. So we'll move him backwards, fill in the area. And so there's the sun. Now that line right here, that's thousands of feet above his eye level. Globe or flat, it's thousands of feet above his eye level. He's only 20 miles away, 400 feet of curvature, whatever it is, thousands of feet above his eye level. And the sun will just go away beyond it, just like it did with the building. It's not below anything, it's beyond something that's way above your eye level. Now, if we add the clouds in, right? The clouds are above the mountain, the sun is above the clouds, and the sun will just go away, and it'll go beyond that line. Now, right here, this line, what is that? That is the top of the mountain. It's also the atmospheric deck. All of those clouds are merging into that line, and they appear to be at the same level. That's called your horizontal eye zone. The sun goes beyond it. And now that's thousands of feet above the mountain, but it still appears to be at your eye level. This is the way our eyes see. This is the way, you've been indoctrinated to think that we're spinning, falling over backwards faster than the speed of sound, and the sun is, stationary from our point of view, and we're falling over backwards and it's going behind a physical ball. It's provably not true. Same thing with the city. Move the city away where it merges into the horizon, and the sun just goes beyond it. Just goes beyond it. Awesome graphics, right? So that gray layer there, that's our atmosphere. So when you're looking up, you're looking through the shortest amount of atmosphere. I'm looking at some stars, whatever in the sky. I'm looking through that little bit of atmosphere. But when I look across to the horizon, I'm looking through all atmosphere. Now this view right here is called an orthographic view. No one ever sees anything orthographically. In a picture, you can depict things orthographically, but it's not how we see. Everything is perspective. So this is how the guy really sees. The ground ramps up, the sky ramps down, and that's how we see. So the Globers like to say, you flat earthers think the sun is 3,000 miles above. I don't know. I think it's a lot closer. But let's go 3,000 miles. 3,000 miles, that sun is directly above him. Okay? So we can draw a line that's 3,000 miles out. We can draw an angle. We can do some geometry and say, okay, at 3,000 miles, the sun would be at a 45-degree angle away, right? So we had another sun another 3,000 miles away, and we draw lines. That first line is 45 degrees. The other one maybe 23 degrees. And they say, you just keep going, and the sun will never set. And they say, from America on the East Coast, Hawaii is like 6,000 miles away, or maybe it's farther. You still should be able to see the sun if the earth was flat. But they're not paying attention to perspective. They're looking at things orthographically. Nobody sees like this ever. This is the angle that they see at. That sun is dropping down. Those are the new angles that the person sees from. They can't discern the space between that bottom red line and the ground because it just merges into the horizontal eye zone. And people say, well, why can't you triangulate the sun? So here we have, I just drew a dome over here. If we have a dome, I think that the sun that we see is an apparent sun. It's an apparent position. I have a little model that if you guys want to see it afterwards out in the sun, it does exactly what I see. So this guy is seeing the sun there. He sees an apparent sun in his personal dome, right? This guy sees the sun there, and this guy sees the sun there. So they're all looking at the same sun in a different place. It's just where they see it, right? So you can't. They don't see it like that. It doesn't work like that. Here's a little experiment I did. I hung a blue sheet in my room. I have a light 10 feet on the other side. And Paige and I are standing here, and I say, "Where do you see the sun?" She goes, "I see it there," right? But then if I move my perspective over and I say, "I see it there," we're both looking at the same sun in two different places in our own sky. So if we tried to triangulate that, we couldn't do it because we're looking at things in different positions in the sky. This is just how we see. This is how the sky appears to us. Another big one is, the equinox. The sun sets on the equator for everybody. Okay, interesting. So here's the equator, and if we, is that playing? Is that moving? Are lines coming in? I can't see. So those lines are, we're dragging those lines from the viewer from all those different latitudes, and we're looking east, and east points to the equator no matter where you are. Go on Google Earth and put somebody wherever and say, all right, draw a line directly east, 90 degrees east, and put somebody there. Now, would you think that if you drew a line directly west, it would go right back to that person? It doesn't. It goes somewhere else, right? That's because Google Earth is hiding the truth of our Earth. The sunset also. This is a good one. We have a guy riding a bike here into the distance, and he's going to mirage out. You can already see that he's mirroring out on the bottom. His legs are doubled. You can see his seat. And I'm comparing it to a sunset. This is the last moments of the sun setting, and he's just literally going to disappear into the horizon. It's a little crazy how it looks exactly the same. And he's just fading out, for those of you who can all see that. And he disappears. Now, he's floating in the air. What's going on there? Right? And the sun does the same thing. And it's not the same every day. It changes depending on the conditions. So the bike rider's still there. You just can't see him. Does that mean the Earth is a globe? I don't think so. Here's one that I did. I filmed this. It has to be super cold, super clear. The sun moves across the sky at about 15 degrees per hour. Therefore, the Earth is a globe. However, if you're up high enough on a clear day and you don't have that atmospheric deck, the sun will stop above the horizon and sit there for 5-10 minutes sometimes, depending on how clear the day is. If the Earth was a globe, it should just keep on going down and never stop. And it just fades out into the thickness. On my app, I have a section right on the bottom there, sun fade out, where there's a whole bunch of videos that show that again and again. People go, well, I've watched the sunset a million times. I live on the water. I've never seen that. Well, you're not going to see it viewing it from the ground over the water. You have to be willing to go out when it's freezing cold and cut off. Whoops, what's going on with my mic here? And you won't see it most of the time from the water. So here is, what do we got here? Oh, yeah. So you don't know anything. You just were born today. Are you falling over forward faster than the speed of sound? Or is that light, whatever it is, coming to you, coming towards you, coming from behind your horizontal eye zone, beyond it, and coming towards you? To believe you're falling forward faster than the speed of sound is insanity. It's just insanity. Here's the moon in Alaska, right? Is that playing? Here it is. So are we spinning, or is that moon just moving across? That's when the moon is over the Tropic of Cancer, and it's just circling the Earth, and it's just going away. It's clearly going away, and it disappears into the horizon. Whoops, going down. All right, so let's talk about why doesn't the sun get smaller? That's the big one. The Glober's like, well, the sun would shrink. It does sometimes, not always. So here is, we have a train, and as it goes away, it gets smaller. Exactly, because this is at the same level. You're at the same. You're on the same level. You're both here on the Earth, right? Here is a sun up in the sky already. On the left, we have the actual view perspective. On the right, it's an orthographic view. That's what's going on. I just explained the perspective. You can see what's going on there. The sun looks like it's going down. It's just going away. Now, if we translated that to the train cars, that top train car is already small because it's far away. So as it goes down, it's not going to get much smaller. I forget the name of the effect. There's a name for it, like Brunelli's or something, or maybe that's something else. But it goes away. But as it gets lower, remember the atmosphere where I said as you look lower, you're looking through more and more atmosphere? As it's going away, it might be getting a little smaller, but the atmosphere is magnifying it a little more the farther down it gets. So that yin-yang balance of magnification and perspective. So that's just a cartoon, Dave. Doesn't work in reality. Yes, it does. So here we have two wiffle balls. In the distance, you see it's the same ball, and it's much smaller. But if I raise this camera up, we're up 7 feet, the balls become almost the same size. Now imagine if I rolled that ball down the track, it's not really going to get much smaller. This is exactly how we see the sun and the moon. It's the same. It's the same thing. You're already far away. So perspective takes care of the whole thing.
But the fool on the hill sees the sun going down, and the eyes in his head see the world spin.
Looks like it's getting smaller to me. Right? When you have a clear, dry atmosphere, you don't have that magnification. And on a clear, when it's super clear and you don't have something eclipsing the sun, it does get smaller. Use a solar filter. Half the time when you're watching the sun go away, if you put a solar filter on, the best part, like the sun fade out, if I had a solar filter on, you wouldn't see the sun at all. It would have disappeared already. Solar filter does knock out glare, but I wasn't talking about glare there. I was just talking about how the sun never goes below the horizon. If I had a solar filter on, the sun, I wouldn't even be able to see the sun, and I would have maybe been a glober. I don't know. So here is, what do I have here? Oh yeah, so I'm just showing you that they always scream refraction, it's bringing the buildings up from behind the curve. Well, when you put, water, the air is liquid, it kind of moves that line downwards. So that's interesting. Here's a shot. This is called Skunk Bay. It's a non-tidal bay. And over the course of the day, time lapse, the beach disappears, the buildings disappear, they go up and down. And every time there's nothing there, the globers go, it's a globe, it's curvature. And then they ignore the other part. They just ignore it. Look, there are the buildings. And then the buildings go away, right? This is provably an atmospheric condition. But the globe, proponents won't really look at that. Here is a, you don't see any boats on the horizon here, but when we zoom out, there are the boats. So we're bringing them back into our visual range. Now, these are terrestrial objects, unlike the sun. Excuse me. And look at that boat in the background. Is it going over the curve? Or is it just going behind ocean swells? This is a day with wide amplitude waves, and they create this horizontal eye zone, which is above your line of vision. And even if it's not, there's a point where the boats will keep getting smaller, but those waves in the distance will be bigger than the reduced size of the boat. I have a bunch of videos on that, but look at that boat in the distance there. Is it coming up and over the curve, or is it clearly just going behind ocean swells? This is a fun one. This person filmed out, and we look out here. Might be hard for some of you to see, but something's going on the horizon. These are dolphins, right? For those of you that can see, the dolphins are jumping and they are way beyond that horizon line, that horizontal eye zone, right? So are they over the curve of the earth, jumping up, going, hey, look at me, I'm over the curve, I'm over the curve, okay? This is just showing you that that's an optical thing. Globers will swear that's the curve of the earth, and you're a moron, right? It's frigging ridiculous, okay? Right? This is one viral on all the mainstream media. Oh, this is refraction. This is a mirage. You know, this boat is refracting up and it's floating. And then these scientists were like, oh, yes, it's because, you know, the water temperature is this and the humidity is this. And they're explaining all of this stuff. They're idiot. They're friggin' ridiculous. If I drew a line there and said, hey, that's the horizon, I'll throw a city in there just to give you a little perspective. What do we see here? This is just a boat that's sitting on smooth water, and there's a wind line in front of them creating some darker looking water. So that boat is just sitting there on the water, and they're claiming that it's refracting up and it's a superior mirage or a fata morgana. It's ridiculous. Here is we're looking at the horizon, and I got these arrows marking it, and then we're on a drone. We pop the drone higher in the air, and we can see farther because we're increasing our angular view. Go to like a big department store or something, a Home Depot, whatever you guys have here, and lay down on the floor. A little weird. And you won't be able to see the floor very far, but then stand up and you can see farther and farther. You're just increasing your view of your angle of view. So here is an experiment we did with, we used a lens, a magnifying lens to simulate the atmosphere. And when we dragged this little boat and sun away, it's disappearing behind a flat table. Now, there's no atmosphere, there's no waves, there's nothing. This is just magnification. Add a couple waves in there, forget about it. This is just, as you move away, this is a flat table without any undulations in it, right? Imagine a pencil lying right in front of that city line, it'll take out half the city, right? And that's just a little bump. Here is Felix Baumgartner. I'll never get it right? And when he did his Red Bull jump, which supposedly proved the Earth is a globe, this is from the ground. The camera shows the horizon right there, and at 127,000 feet or whatever it is, it didn't drop. The higher you go, the farther you can see. The farther you can see, the lower the horizon should be if we live on a globe. So at that height, the horizon is 618 miles away. At 618 miles, there's a 250,000 foot drop. So add that to the height of the balloon, and the ground is supposed to be 381,000 feet below his eye line. Does that look 380,000 feet? None of you can even fathom what 380,000 feet is. That's nothing. So, you know, Neil deGrasse Tyson wants us to say, you can't see the curve from 24 miles high, right? But you can see rockets curve over the Earth, right? It's so big, but these rockets are supposedly going around the Earth. It's friggin' ridiculous. This is the Go Fast rocket. Now, this is better than a NASA rocket or a SpaceX. It's one continuous shot. NASA would have had 7 cuts already. Right? And then all of a sudden, it hit something, and it was floating very strange. So we can argue all day what it hit. I think it hit a layer of plasma as it's going. But what's interesting is when it turned on its side there, all of a sudden you can see the moon. Can you guys see it? It's hard to see, but the moon's right up here. There's a side camera and a down camera, but they never put cameras on the top. Maybe because, I don't know. But that's okay. We can see the moon. What does that mean? Well, this was taken off in Arizona, which is right there. So it's 11 o'clock in the morning. So it's noon right here as the sun moves across. That makes it an hour earlier. So it's 11 a.m. when it took off. So that's where the sun was, but the moon was over Australia, right? So if the Earth was a basketball and that rocket was on the top of the basketball, it went a millimeter over the basketball, and the moon is below the basketball. How do we see the moon? If you live on a ball, there's a set rate of curvature, whatever the size of the ball is. 24,901 miles around, they tell us our Earth is. So there's a rate of curvature at a certain distance. There's a physical horizon blocking things in the distance, right? We can see these mountains that are over 700 miles away. Calculating with using their math, their globe math, using the formula that gives the globe the best benefit of the doubt, right? From this altitude, those mountaintops that all those red arrows are pointing to should be over 50 miles below a physical curve, but we can see them. And over on the left there, those yellow ones, those are even farther. So what's going on here? You know what mainstream media says about this one? Nothing. They pretend it doesn't exist, right? Or they say, you're lying. You're lying. These are things you can go verify yourself. So their only thing they could say is refraction, that all the mountains are refracting up 50 miles and stopping at eye level to trick you that the Earth is flat. Or maybe the Earth is flat. Maybe. Large bodies of water at rest lie flat. When it's cold, they freeze flat. And we have a canal here. Guy went out at night. He's got his super zoom camera 6 inches off the ice. And he put these lights out here at different distances, 8 miles, 7 miles, 6 miles, and 5 miles. According to globe math, rounding down, giving the globe every benefit of the doubt, adding refraction in, the one on the left should be 30 feet below, 22 feet, 15 feet, and 9 feet, but they all refracted up in the dry, dark air and lined up at eye level to trick you to think that the Earth is a globe. I mean, to trick you that I don't know. It doesn't even make any sense, right? It's so dumb. It's friggin' ridiculous. Here is a spot from Canigou, Luge, France, looking out over the ocean, and it's 275 or 175 miles away is Mount Canigou, and you can't see it, right? So do you guys see me right now? You do. You see the light that's bouncing off of me, but if we made this pitch black, you wouldn't see me because there's no light bouncing off of me. The light that's bouncing off of that mountain cannot push 175 miles through all of that atmosphere. It's not bright enough, but the sun is. And twice a year, the sun lines up with the viewing spot and Mount Canigou. And as it goes away, it backlights the mountain. And there it is. The whole mountain is there where the top should have been almost a mile below the curve. Right? So twice a year, you can go witness this yourself. Well, so the Earth must be bigger then. It must be bigger. We have observations that would make the Earth over 1,000 times bigger. Right? 1,000 times bigger, I would say there's 1,000 more continents then. 1,000 times the number of continents. So that's 8,000 continents. What are they hiding from us? Right? So NASA official picture from 100,000 feet. Beautiful curved globular Earth, and amateur weather balloons even higher, flat. Who's lying? Someone's lying. Circumnavigation, that's a real easy one, and you could just understand this yourself. Very easy. I got a magnet, and I put it at the center. Whoops. Can I go back? There we go. I did it. Let me hit play. So I got a magnet. That compass is pointing towards the north. And I went west. Now I'm going east. And east is a circle around a globe. Now, if I try to dead reckon west, that stick is pointing west, and I follow the stick, I'm immediately heading south. South is every direction away from the center. If this was the North Pole, magnetic North Pole, my compass would point towards it. So that way is south. That way is south. That way is south. And that way is south. South is every direction away from the center. East and west are circles. This does not prove that the Earth is a globe or flat because it works the same on both in the north. In the south, it works, it's still a circle, but in the north, when I'm going west, I have to constantly turn to the right to go around the north to make it back at the same heading. South of the equator on a globe, I would have to turn left to go around the South Pole, but that doesn't happen. We have reports from ships captains, military people, that they always have to correct to the north, right? So there's some experiments that could be done there. Amelia Earhart, she just went around, right around. So there's all her stops. She went east or west, whatever direction she was going, and she circumnavigated the world. They say there was a flight that circumnavigated the poles, TWA flight or whatever, Pan Am, whatever it was, and it went, from the North Pole, went, around and to all these different places, through Russia and then down to by Madagascar and down to the South Pole and then back up through South America and around the North Pole. Boom, Earth is a globe, right? Let's look at that on a flat Earth map, right? That's all they did. That's it. And they say that proves the globe. But someone that doesn't understand this will just be like, oh, yeah, that proves the globe. That's all they did. Airplanes fly straight and level over the Earth plane. They don't nosedive down. Here's a news report on a solar plane that circumnavigated the world.
To prove its potential, they began flying it around the world, around the world, around the world, around the world, from Abu Dhabi last year, with stops in India and China, then across the vast Pacific. Remember, it has no fuel. If it was onto the United States, hopscotched across America, powered only by the sun. And now it has crossed its last.
They always have to tell us the truth.
Around the world, around the world, around the world, around the world, around the world. To prove its potential, they began flying it around the world.
So just imagine that is an airplane. That's how our sun circles around the world. And airplanes do the same thing. They just fly around the world. Another one they come up with, the Globers come up with, they're like, how did the Japanese attack Pearl Harbor? Well, that's a whole nother psyop. But, they love, go back. There we go. They love saying, how did that happen? Well, this is ridiculous. This isn't even true on the globe. This is just a stretched out, cut up, cut at the dateline. This is how they attacked Pearl Harbor. Right there. Japan, Hawaii. Right there, short flight. Easy schmeezy, all right? Talk about airplanes, okay? Airplanes, the airplanes are the best, right? So there's nothing in our manuals anymore. This is a pilot. Nothing in our manuals anymore that are required to know how anything works. In flight school, if we're asked a question on how something works, they say you don't need to know that. I have lots of pilot friends that seniors at American Airlines, Qantas, and other airlines, and they say when they were first flying these planes, they had to know how to rebuild it, or they weren't allowed to they weren't allowed to fly it unless they knew everything how it worked. Now they don't. You just become push this button, turn this knob, and land the plane. This is the rate of descent. A pilot has to calculate the rate of descent. So when they're like 100 miles out from the airport, they're like, okay, we're going to be heading towards the airport. And they have to figure out how many feet per mile they need to drop down so they can hit the runway. And they do that calculation. At 100 miles out, if they didn't calculate for curvature, they'd be over a mile too high. They'd be over a mile too high, right? On my flight here, pilot said they're starting their descent at 225 miles out, 6 miles too high. All right? We got to the airport. If he didn't calculate for curvature, which he doesn't, we'd be 6 miles too high, right? Because the Earth is dropping away as you're going. They don't calculate for curvature. If you want to fly an airplane, you have to treat the Earth as flat, level, stationary. Otherwise, you're all going to die. All right? So let's go back. This is what you believe is going on, right? If you believe you fly around the world, you're doing this crazy figure 8 pattern, upside down, turning, changing speeds, right? It's moving at the equator 1,000 miles an hour sideways, but at the poles it's just pirouetting, right? How does it speed up and slow down? It's so dumb. It's speechless. But when you're on a plane, this, you're always at the top. When your point of view is you're always at the top. So as you're diving over the ball, those stars in the distance are rising up. Okay? Think about it. Like I'm looking at people in the back there. If I was flying towards them, but the Earth is a globe, your stars, as I dive over, I'm looking that way now, so they're directly above me. So those that's what we should see, right? So here is just an example of that. So that airplane is looking at those stars, and as he's flying over, he's now looking at in a different direction, and those stars are over his head, right? That's what we should see, right? That's what we should see. So here is a flight from, I think it was Germany to Brazil, 4,000 miles. They're going halfway over the globe. So those stars that are on the horizon should be at the zenith over his head, but they're not. They stayed on the horizon the whole time. The movements you're seeing are just when he's turning. This is what Google Earth says you should see. For those of you who can see it, the stars are rising up because they're diving over a ball. But that's not happening. Reality versus Google Earth. Which one are you going to believe, right? They want you to believe Google Earth. Do you know that in 2001, Google Earth was flat? They added curvature right after 9/11. Right? Because people are starting to like, wait a minute, why is it flat? So satellites, that's another one people say, well, how do we communicate? How do you guys talk to us? There's undersea cables everywhere, and I think these cables are way older than they're telling us, most of them. But there's no cables connecting Santiago to Australia or the southern continents. They go all the way up, right? Here, all the way up, and then all the way down. That makes no sense, right? But if you look at it on a flat Earth, all those cables make perfect sense. So what are satellites? Well, here's a satellite. They have these balloons. There's thousands and thousands and thousands of them. They're up. They go up. They can stay up for years, and they can control where they go. So I'm not even saying that these are communication satellites. They have all sorts of stuff up there hanging on balloons. Some of these balloons are bigger than football stadiums, right? So another one of my pilots, he said, we received a message that 2 NASA balloons are descending from 55,000 feet in our airspace, and they have no transponder. Now, he's a flat earther. He knows about these. He knows these things weigh up to 8,000 pounds. His co-pilot is a Glober. He's like, oh, that's cool. And this pilot, he's crapping his pants. He's like, holy crap, if we hit this thing, that could wipe out the whole plane. So he's like, everybody put your seatbelts on, making everyone sit down. But nothing happened. He never saw the balloons. But it's interesting that, they said these NASA balloons are passing. Like, how come we don't hear about this? You guys fund NASA, or you don't. We do, right? We do. $80 million a day. People say, I know it's hard to see. We have the satellites, the Starlink satellites. Have any of you guys ever seen that? The Starlink satellites, the row of satellites going by, right? So this is all a trick. It's all a trick, right? So we can see these lights in the sky. Interesting. So here's a 747 on the ground and a 747 laying a chemtrail right there. You can barely see the plane, let alone you cannot see the engines because they're too small, right? So that's 7 miles high, right? A Starlink satellite is about the size of a man, right? You see that man standing next to that engine? It's very hard to see. He's very small. How many can you fit inside that engine? A bunch. 10? 20? I don't know. But it's way smaller than the engine. So we can't see an engine at 7 miles high, right? But we can see Starlink satellites at 340 miles high, okay? You cannot resolve that. You can't see that, right? So what are those lights in the sky? I don't know. I think it's all a big deception. I have some ideas, but we can discuss that if you want later. So Starlink service, you can get it. So what is it? I think that they're connecting to airplanes, and airplanes have all of the communications that we need. They're like giant, just think of them as cell phone towers that are really high that we have access to from almost anywhere, right? So here are, these are all of the satellites that are orbiting the Earth, supposedly, right? So, is that going to play? There we go. Whoops, I got to go back. Didn't play. Here we go. I don't know if you can see it, but there's satellites going in all different directions. We're whirling and twirling and swirling in all these different directions, and these satellites are just magically following us, okay? It's frigging ridiculous, okay? It's frigging ridiculous. I'm actually using different words in my head, okay? Here's a real Earth satellite, and here's a Globetardia satellite, all right? These are just all cartoons. There's no images of satellites. You want to learn more? In the app, there's a whole section on satellites. These are all videos that you will not find on Google. They won't let you find these. Even though they're there, they won't find them. What about gravity? Gravity, Dave. All right? You don't believe in gravity? Try stepping off a roof of a building. That's what they tell us. All right? Walter Lewin, MIT professor, says it's electric forces that hold our world together. Right? And that is the truth. All right. So our world is a giant battery. We have the sun and the moon, which are the anode and cathode. The salt water carries the current. The land is the salt bridge. It's just a big giant battery, right? Flat earthers are absolutely crazy because we think down is down, right? Globe earthers on a spinning ball flying in all these different directions think down is every direction towards the center. So mass gets together and says, oh, come toward the center. Let's say you're the molecule at the center of the Earth. Everybody come to me. And then some other molecule halfway between the center and the surface goes, no, everyone come to me. I'm the center. Who said that's the center? Why? How does that work? Gravity is an unproven theory. Buoyancy and density sort everything out. That blimp is lighter than the air. It floats in the air. The boat's lighter than the water, less dense. And the submarine's more dense. So buoyancy and density, but what makes things go down? Now, there's a lot of controversy on this. People say, well, down is just down. There is a testable, measurable force called the electrostatic force. So here we have some helium balloons left over from a little party, and we have them tied to this button, and it's off the floor, just neutrally balanced. We add a positive charge to it with a Van de Graaff generator, and it goes down. What do? Do we just change gravity? Then we discharge it, and it goes up. Interesting. The Earth has a negative charge to it. Here we're adding a negative charge to this, and it goes up. So we're manipulating the electrostatic force and making things go up and down. We test it, we measure it, we show it. That is science. So could there be another force? Maybe. Maybe there's gravity also. Okay, so here is, this is called the Silent Drone made by MIT. No moving parts. It looks like a big milk crate, and it flies. It's just changing its electrostatic force. It has a strong negative charge to it, so it's able to fly. Is it anti-gravitic, or is it electrostatics? Right? So we can test and measure and prove electrostatics. The globalists say that electrostatic force is 10 to the 36 power stronger than gravity. Can you guys fathom what that number is? Because I can't. Right, 10 to the 36, right? I don't know if I have a slide in here, so I'm going to talk about this now, but if I get to it, I'm going to skip over it. So a trillion, those of you listening to me, you know how big a trillion is. 1 trillion seconds is 31,000 years. Just let that sink in. 1 trillion seconds is 31,000 years, right? So let's say Ian was over here and he told me a bad joke and I punched him in the shoulder. I said, that's a stupid joke, okay? And let's say I did it 1,000 times harder, right? It'd probably send him to the ground. If I did it 100,000 times harder, probably kill him. 1,000,000 times harder, he'd probably explode, okay? 1 billion times harder, I might take out half of the country. I don't know. That's pretty strong. And 1 trillion times harder, you can't even fathom it. That's 12 zeros. If I made it 1,000 times stronger than that, and then I took that number and 1,000 times stronger than that, we're only up to 18 zeros. I got to keep going up to 36, right? So the electrostatic force that we just tested and measured and proved, they say is a very weak force, but it's 10 to the 36 power stronger than gravity. That means gravity is zero, okay? Zero. If it was only gravity, affecting my phone, I could leave it here in the air and it would take 1 billion years to hit the ground because there's nothing pulling it down. Okay? Nothing pulling it down. You want to learn more about gravity? There's gravity right here. And now I was just showing that slide. I didn't realize I was showing it. That's they make it rain. They can control the weather by just changing the electrostatic charge of clouds, and they can make them drop the water whenever they want. There's a gravity button on the app, and so you can learn more about that. So here's my slides. A trillion seconds, 31,000 years. That's 12 zeros. The 10 to the 36. That's what it looks like. That's a trillion, right? I guess I did have that, and everything I just said. So there you got that. Tides. That's another one. The moon affects the tides. I think the moon does affect the tides, but that's not the cause of the tides, right? There's these things called tidal nodes, and there's these spots in the world that have no tides, and a high tide and a low tide circle around that every day. So that completely blows away the idea of the moon. So here we have the moon. They say it's pulling the water. That's so we got the water right there on the side of the moon. It's pulling the water, but there's another high tide on the other side of the world at the same time. You know why they say that is? This is Neil deGrasse Tyson, the head of scientism. He says the moon is pulling the water from the earth, but it's also pulling the earth from the water on the far side because the earth is closer to the water. So the moon is pulling the earth away from the water, causing a high tide. It's frigging ridiculous. Okay? It's absolutely ridiculous. This is a full moon, right? Full moon. So you got the moon pulling the water, you got the sun pulling the water. But when there's a new moon, the sun and the moon are pulling the same side, but the tide isn't the highest. The tide is higher when the moon is powered up, when it's full, right? So there should be gigantic tides if the sun and the moon are both on the same gravitational side. Are all the planets flat, right? These are new planets from that they found recently. Actually, they're frying pans. If you watched Ian's thing, this is just a frying pan. It's an old frying pan, right? It looks better than some of the stuff NASA gives us, right? But why is everything in the sky spherical, right? Well, why are your lights spherical and your floor is flat, right? So is this the sun or the moon? Is it the sun or the moon on the horizon there? A little hard to see in this bright light, but it's neither, right? It's actually a train. And it has rectangular lights, it has blue lights, it has orange lights, it has green lights. But we see it as a sphere. It's the way our eyes work. Here is Jupiter. One of our probes went by Jupiter. This is over a couple hours, couple days, couple weeks, doesn't matter. You got the winds. That circling storm is bigger than the Earth. It's been going forever. Okay? Look at those clouds. Look at the changes in this gassy atmosphere. Okay? Here is on the bottom is the 2014 photo of Jupiter that they showed us. And then 2016 they go, oh, Jupiter has a magnetic core. We filmed the northern lights. Look at those northern lights. Could you guys recreate those northern lights in MS Paint, let alone Photoshop? Right? And if you look at the clouds, they're exactly the same. Wait a minute. Didn't we just watch the clouds changing? This is over 2 years apart, and the clouds are exactly the same. They're lying to everybody, and people are just too lazy to say, if you're lying about that, everything else, you're lying about everything else. They're lying. They're lying to us on all layers. This is what NASA gives us on the top, and on the bottom, this is what reality shows us. Right? Well, NASA has better telescopes, Steve. You know, it's nothing like that. On the top there, nearly 1,000 Earths could fit in Jupiter. Nearly 1,300 Jupiters can fit in our sun, and then 5.1 billion suns can fit into this other star. Friggin' ridiculous. Okay, it's just stuff that you can't fathom. Saturn. Great picture of Saturn they gave us. We took it off their website. We put it in Photoshop. We cranked it up, and we could see all the layers. They patched it together. They did a horrible job. I'll do it for less, right? I can make better ones. You know, I only charge $10 million for a photo like that, right? They get $80 million a day for this nonsense. But they did recently find this other Earth-like planet, which is kind of amazing. But the problem I have with it is it's land on the bottom and water on the top. So wouldn't it not spin well? You know, it's kind of off balance. I don't know, right? But as they zoomed out, we actually realized it's just a old tank of no, old fire extinguisher, right? Right? That's just a fisheye lens that costs nothing to do. It looks better than what NASA gives us. So here's a question for you: is this Mars or is it someplace on Earth? Is that Devon Island? You think? Right? Is it? Is that Mars or is it someplace on Earth? I think it's someplace on Earth. Actually, I think it's the moon. Right? I think it's actually the moon, or it's possibly a place in New Jersey where there's a construction site. To be honest, the first picture, I forget if I made that picture or if that actually was a Mars picture, because they all look exactly the same, right? They look exactly the same. Here's a shot from the rover on Mars showing the helicopter. And if you look at the shadow of the helicopter, it's pointing one direction, but there's no shadow on the camera post on the rover. How is it selective shadows on Mars? And here's a sun setting. They're showing the sun setting, but if you look underneath the solar panels, the shadows are directly below them, like it's a 12 noon sun. Is there two suns on Mars? Right? That alone shows you that they are lying, right? So here's one. We found one of their. This is just a photo from them. We're zooming in. And we found life on Mars. Look, there's a bug. There's a fly on Mars. This proves that there's life on Mars. 100%. 100% proves life on Mars. All right? And that's I don't even think they address this one, but they would say, well, we don't want to let people know there's life on Mars. Ridiculous. Absolutely ridiculous. Another thing Globers like to do, they love looking at the ceiling to prove the shape of the floor, right? Something they can't touch, they can't prove, right? They say the stars rotate in a different direction. Well, if the sky is liquid, I don't know. We could be seeing a reflection of rotation. There's a lot of reasons that the stars move in a direction, and we don't know what the actual answer is. One of the things that the Globers say is that, well, if you're in Santiago and South Africa and Australia, everyone's looking south in different directions and can all see the Southern Cross. Well, one, you can't see them at the same time because it's noon in one place and midnight at the other. But there is one day a year for 20 minutes that if you were at these extreme locations, you can see the Southern Cross at the same time. But, hey, get away from me. Whoops, I went back. Sorry about that. You can see the Southern Cross at the same time, but from South America to Australia, you would be looking at it upside down. The Southern Cross would be upside down, but it's not. It's still in the same basic orientation, right? There's a whole bunch of videos on the app in the Southern Star rotation area that you can watch that you will not find on YouTube, right? This is our sky. This is a time lapse of what? The Earth rotating or the sky rotating? Right? Then a photographer said, you know what? I can get a camera on an axis and focus on one star, and I can make the Earth look like this. And the mainstream ran with this, going, proof the Earth is rotating. Scaling invariance is how they lie to us. They say the sun is 400 times brighter, 400 times bigger than the moon, but it's 400 times farther, so it looks like it's the same height. I mean, the same size. So one astronomical unit is 93 million miles, right? That's 8 light minutes, right? So two times that, 4 times that, 8 times that is 1 light hour. 8 times 8, 36, 64. So a light hour. Double that again, it's 2 light hours. Double that again, it's now the size of a star. You can't see it, but it's very small right there. Tiny little star. So at 4 light hours away, the sun looks like a star. So they tell us, let's make that, so 4 light hours is the size of a star. Let's just be safe. Make it 200 times farther. Okay? Just giving the globe an extra 200 times that distance, right? That's 4 4 light hours, that's 33 days. We'll call it a light month. So at a light month away, they tell us Polaris is 46 times bigger than the sun, right? So if we made it 46 times that, 46 times, it would be 4 light years. So at 4 light years away, we are amplitudes too far to be able to see Polaris, way beyond where we could possibly see it. And they tell us Polaris is how far away? They tell us it's 433 light years away. Again, most people just short circuit when they hear this because their brains can't fathom it because you weren't taught big numbers like this. So once you understand that, if you can't understand it, I can't help you. But you have to think about that. You really just have to think about it. This is on the 0G plane, and can you guys see that at all? Right? So they've got some ping pong balls there. And what I'm showing here is all of that movement, the ping pong balls are changing positions. Everything changes positions. We're twirling and whirling and twirling through the sky, and none of the stars ever cross each other. As I move across the stage here, all of your heads are changing positions. There's a guy on the left of her, and now he's on the right, and that's called parallax, but there's no parallax ever. No two stars ever have changed positions. They should change positions every single day, right? Stars are not what they tell us. I hope you guys can see this one. This is my favorite. This is a star, right?
Stars, we were told, are distant suns. Is this what they look like to you?
Right? You want to know what this is? So do I. I think stars are angelic. I think they're perfect. And they all play a big role in our lives here on Earth. Right? You're supposed to believe that that's an impossible gas ball in a space vacuum burning at trillions and trillions and trillions and quadrillions of miles away. When it's really right here in focus, the same focus length as the moon and the sun and the other stars, right? Here is, this is another star, completely different. A little hard to see, but we'll just continue forward. Photos of Earth, that's the big one. This is the one that was on everyone's iPhone, the blue marble. And if we take a close look, most of you have seen this, that they've photoshopped the clouds, right? And as Robert Simmons said, the guy who made it, he goes, I made it in Photoshop because it has to be, right? He just made it from data and then he wrapped it around a ball. What about shots from the ISS? So for those of you, if you can see, there's the big curved Earth up there. But if we take all of that and we look, whoops, that right here, that little circle is what this whole thing is. That little circle is what the whole thing is, right? So this is just a fisheye lens from an airplane or a balloon at best. Here's the United States taking up most of the globe. So here's a map of the world. If we drop the globe in there, all of the other continents, all of that is on the other side of that ball. Okay? A game over. This is a cartoon you're looking at. It's a cartoon, right? Here we can actually measure across Mexico, and we could say that's 934 miles. They say the diameter of the Earth is 7,917. I should be able to fit all of those spaces and more in between those two red lines, and you can't because it's a cartoon. It's made up. It's nonsense, right? And this is a picture that says, they're saying since 1978 the pollutions are very bad and the global dimming. Look how dim it is. The one on the right is much dingier color, but none of the clouds have changed. None of the clouds have changed in all of those years. Right, these are NASA photos. Okay. So here is a NASA 1972 photo taken from the moon. Well, we know exactly when it was taken, so we know what the day, what the light was. And if we look, we should see all of South America should be in the light and much of Russia. Go back. Where is it? Where is it? It's not there because it's a cartoon. Okay, this is a photo. These are both paintings. That's a painting. For those of you who can see it, that's called a photorealistic painting. Which one would be harder to paint? All right? Which one would be harder to paint? Here's a hurricane that was 400 miles wide that NASA showed us. 400 miles wide. Let's put that ball in contrast and put a map underneath it. And that means America is less than 400 miles wide, right? Again, most people don't bother to do any of this, right? What I got there? I got a blank screen. There's tons of photos. You just type in Earth on the app, and you could examine all of those photos. Eclipses, I'm going to hit it real quick. I'm told I only have 5 minutes, but I'm going to take 10. Okay? All right? Oof, I got to go fast. All right. So someone asked earlier about the eclipses. Here's an eclipse of the moon. Well, that means the Earth has to get in between and cast a shadow on the moon. There's many, many problems with that. So this is how it would go. The Earth would come up, the shadow would come up, and then the Earth would pass, and you have this beautiful shadow. But this is called the Selenilian eclipse, and it started before the sun and the moon were set, and the eclipse came in from the top. What does that tell us? It tells us it's not the Earth doing it, right? So we can look farther into that. It's not the Earth doing it. Here is some eclipses of the sun. This is a solar eclipse. Do you see the moon? Do you see the moon there? Do you see the moon there? You see missing sun, right? It's just missing sun. You can imagine it's the moon, but there's something else going on there. Again, the eclipses section on the app is will show you all of the videos that you're looking for. Day and night. Here is if the Earth was a globe, there would only be 50% lit at all times. It would always be exactly 50%. Single source light, a sphere, no matter how you tilt it, wobble it, spin it, it lights up exactly half of it, except on July 8th. July 8th, they say 99% of the world is in light. That's misleading. It's just over 70% of the Earth is in daylight, right? 99% of the population. That's because everybody lives in a certain area, but over 70%. Right? This is the graphic they show you. How does a single source light light up more than half of a ball? It doesn't. It doesn't. This is, again, from NASA. It doesn't. But if you look and if you use a light, we have a light and a dome here. It shows you how the light changes its amount of Earth that it's showing. And it happens to match day and night. Perfect from time and date. Southern flights. Here, we're going to go through these fast. Here's the World Cup. It was in Doha, and then the team won, had their own flight. Then no picking up passengers, no stops anywhere for any other reason. But they stopped in Rome for fuel. Does that make any sense? Right? But on the right, it's on a flat Earth map. It's a straight line. Here's another one. Rio to Sydney, stops in Los Angeles. Makes no sense. Look at it on the flat Earth. It makes perfect sense. Buenos Aires to New Delhi, stops in Amsterdam. Ridiculous. Frigging ridiculous. All right. Sydney to Lima, Peru, goes all the way up to the north to Los Angeles on a flat Earth. It makes perfect sense. And these go on and on. So I'm going to whip through them. Here's one from Southern Africa to Western Australia. They either stop in Dubai, Hong Kong, or Malaysia. But if you look at that on a flat Earth map, makes a lot more sense. Makes no sense on a globe. I'm going to skip over that one.
To make an emergency.
Skip over that one. Here is one. New Zealand to Argentina should just go across the bottom of the ball. That's the great circle route, right? But it goes all the way up to San Francisco, Houston, and then Argentina. Look at that. All right? Look at it on a flat Earth map. New Zealand, San Francisco, Houston, and Argentina. You couldn't get a straighter line, right? That's just a coincidence, though, right? Right? There's all of these counter-rotating wind patterns up to 350 miles an hour that these airplanes can take to make up these distances. And on the app, I'm going to skip over that. You have all of these things. You can check them out and verify this stuff yourself. Emergency landings, that's another one that gets everybody. Here's a flight from Hong Kong to Germany. It stopped in Germany. It was supposed to come here to the UK. But 4 hours into this 12-hour flight, the mother traveling with her little kids and her husband dies. Died suddenly. What happened there? Right? And 4 hours in, but they didn't land for 8 hours. So you're sitting next to your dead mother for 8 hours. Why didn't they land? Why didn't they land? There's so many places. But if you look on a flat Earth, they were over Russia. That makes no sense on a globe, so they couldn't land because Russia, one, would be like, oh, let me help you, and that could spark peace, right? So, so, and also we could say, why did you stop in Russia? And then we'd have rock solid proof, but they can't let that happen. All right, so going forward, and there's a book called The 16 Emergency Landings. You can find it on my website, and there's also a free PDF online. Meteors, right? Here is, we always see these meteors coming in at these angles like that. Somehow they come in at these sharp angles and create these beautiful circular craters, right?
And look at some of the other. It came out of nowhere.
Came out of nowhere. This is just a military fireworks show. Here is a guy that filmed this in the desert in America where they're doing testing, and they're shooting out these weird flares in the sky that look exactly like these meteors that are coming in, right? So this is them, it's the same thing. And they're calling these meteors. So this is just to make you think that rocks are falling from space. Geysers versus craters, they look exactly the same. Because they are the same. Meteors, I don't know if you can see this. Whether you can see it or not, you're on a globe and I'm watching a meteor come down. Somebody in South America on the southern hemisphere would see a meteor going up. No one has ever seen a meteor go up. They only go down no matter where you are, okay? No matter where you are, they only go down. NASA is a bunch of snakes, founded by Ronald Hubbard, founder of Scientology, cartoon film producer, ex-Nazi, an occultist, and Aleister Crowley, one of the sweetest guys on earth, right? Werner von Braun, his gravestone, Psalms 19:1, says, the heavens declare the glory of God, and the firmament show us his handiwork. Is that revelation of the method? Is that a deathbed confession, or is that just them poking us in the eye? Let's skip over that. Werner von Braun wrote a book in 1957 called Project Mars about a group of people that went to Mars, headed by a guy named Elon, right? He wrote a book in 1957 about going to Mars with a guy named Elon, and now we have Elon Musk and SpaceX. He's going to Mars. I'm sorry. Right? And I need to take a moment to show this one. We're getting there. We're getting close. We okay? You know what? We're going a little long. Right? So this rocket goes up. Look at that little flame. This thing weighs tens of tons, right? And look, edit. We've had like 5 edits already and 6 edits. Now look,